So let's talk about naming carboxylic acids. And this is going to be one of those ones we're going to keep it simple when we name the compounds because, yeah, once you start tacking on like dozens of functional groups, it gets really hard to name these compounds and it's kind of outside the scope of this class. What we want to focus on at this level organic is just understanding the basics. So we're going to use the substitutive class of naming for naming these types of acids, and the way we're going to do that, particularly for a chained alkane, is we're going to count the number of carbons. So in this case I got 8. So we're going to have octane as our parent compound. How do we designate that it's an acid? Well, we're going to use OIC and add acid to the end. So this tells you you've got the RCOOH functionality, O and acid. Now, we don't have to specify the position, and the reason we don't have to specify the position is that carboxylic acids come at the very end. And on top of that, this is going to be our primary functional group for the compounds we're going to be looking at. So since this is our primary functional group, we're going to make it part of the parent chain, and we're also going to designate that as carbon number 1. Now, if you were to put two groups on them, let's say we put a methyl and a methyl, well, let's just do two methyls to keep it easy. If we have methyl groups, we're going to do it the way we've always done it. You can read it right to left. So we get the parent chain, octane, it's oic acid, and in this case we have 5,5 dimethyl octanoic acid. What if I threw an alcohol in here instead? So I had 5 OH. Well, the alcohol here is going to be considered a substituent of the main chain. The alcohol does not work over, or is not, it's considered lower priority over the carboxylic acid. So in this case, it's going to become 5 hydroxy octanoic acid. Now, the last one I can throw on there beyond methyl and alcohol substitutions are your double bonds and your triple bonds. Well, how do we designate those? Well, it's kind of what you expect. This A here implies an alkane. So, let's say I put a double bond there. Well, this A is going to become an E, octenoic. We need to specify the carbon position, so 3 octenoic, and we've got 5 hydroxy. And we also need to designate that whether it's an E or Z or cis or trans, and since we kind of see that we have the two higher priority groups opposite each other, this is E5-hydroxy 3-octenoic acid. So that's all that really gets involved with naming simple carboxylic acids. Let's say you had 2. Well, let's get rid of our functional group so we can keep it simple. If we have 2 carboxylic acids, instead of having oic, well, what did we do for the alkenes? We did the diene, right? How about the alcohols? We did the diol. It's going to follow the same line of reasoning. It's octane dioic acid. And again, we don't need to specify where they are. Carboxylic acids appear on the ends of the chains. And because they appear on the ends of the chains, we don't have to specify where they are. We know what's on the ends. So this is the gist of how you name simple, linear, even with some functional groups, carboxylic acids and dicarboxylic acids.